Hello everyone, welcome back to my channel. So this is the seventh video. So this is a continuation of the half adder where we have seen already a theoretical aspect. Now we are going to see the practical aspect. In practical aspect I said that I am going to implement this two circuit using XOR gate and AND gate, and these are three AND gates and one OR gate. So this becomes complex when we don't use the XOR gate. I'm going to show the both the circuit. So these circuits are of half adder. So this is a truth table of half adder, which is 0 0 gives 0 0, 0 1 gives 0 1, 1 0 gives 0 1, 1 1 gives 1 0. This is carry, this is sum. A and B are the inputs. So these are the equations which were derived from the K-map in the previous video, A XOR B and AB. So I'm going to implement this both the circuit with XOR gate and without XOR gate. So let us implement the circuit using, we require one breadboard and require one XOR gate and one AND gate for this first circuit. We will implement the first circuit, then we will go for the second circuit. So to implement the first circuit, I have took one AND gate IC, which is the number is 7408, and second one is XOR gate, the number is 7432. So take these two ICs. The picture of the ICs may be coming on the screen. So first, whenever we connect an IC to the breadboard, first connection we should make the number pin 14 and 7. So 14th pin VCC and 7th pin ground, and here 14th pin VCC and 7th pin ground. Other all connection you should do afterwards. First connection must be the VCC and ground. So this becomes first connection. So now for the implementation we need one XOR and one AND. You may be knowing one IC contains of 4 gates. So this contains of 4 AND gates and this contains of 4 XOR gate, but we want 1 gates. So I'm going to use 1 and 2 as a input, and third one is the output for AND gate, and 1 and 2 has a input and third one is for a output for a XOR gate. So let us make a connection according to this diagram. So these are the AB pins. So we are going to leave 2 open wires. I'm using yellow wire as an one open wire for AB. So this is the connection. So this is how it has to be connected. So first pin is a which I used a yellow wire, and second pin is a B, which I used a green wire. Now this is an AND gate. So AND gate is having AB pins. From here this is A and this is B. Now we will short it from XOR gate. So this is first pin is as a and second pin as a B. You can use any gate from the IC. I am using the first gate. So first pin has a and second pin has a B. Now we are going to short it from this first pin to this first pin, this second pin to this second pin. So the connection is completed here. So first pin is connected to AND gate, second pin is connected to AND gate. So the first pin is connected to the AND gate and second pin is connected to the second pin of the AND gate. So now we should connect an LEDs for sum and carry. One LED is connected to the XOR gate and second LED is connected to the AND gate for carry, and this is for sum. So where we have to connect, that is AND gates, it is third pin as output, and XOR is also a third pin as a output. First we will short the gates. So I have shorted the first pin to the first pin and second pin to the second pin. So this first pin is yellow wire and second pin is a green wire. Now I have shorted. Now you have to connect the LED at the third pin of the IC, both the ICs, for the output of sum and carry. So I'm going to use 2 LEDs of this type to connect to the third pin. So third pin is connected in this format. The longest strand of the LED must go to the third pin and shortest must be grounded. So the longest strand is a positive and the shortest strand is the negative. I have already told in the many videos of my previous that long one is a positive and short one is a negative. So let us connect the LEDs. So I have connected the LEDs at the third pin for both the ICs. Now to check the, and now we have to check the output. Now we have to connect the battery. I'm given a voltage by using a small battery. So that red wire is an VCC and this black is for grounding purpose. So one battery must be used for giving an voltage. I have given VCC this side and ground this side. So this whole line is for ground and this second line is for VCC. So now let us verify the truth table of half adder. So first input is when you give 0 0, both carry and sum must be 0 0. It means both the LEDs must get off. So let us give the 0 0 condition. So I am going to connect both the wire to the ground. So A, B are now being grounded. See, both the LEDs got off. Now for the second condition, that is 0 1. For 0 1, carry must be 0 and sum must be 1. So let us give A has a 0. So now A is being given as a 0. So now A has been given as 1 and B has been given as 0. So the sum LED must get on. So sum LED is this one. So it has got on. So now for second input, we have to make interchanges. Now A has to be given and B has to be given 0, but the output remains the same. So let us exchange the wires. So this yellow wire must be given as, so this yellow wire has to be given as 1 and green wire has to be given 0. And this green wire which is B, which has to be given as 0. So it must be grounded. So B is grounded and A is given as 1. So the sum must be 1. So the same output has been came. And for the next input, A and B both has to be 1. Sum must be 0, carry must be 1. So now by removing this B, when both A and B has been given as 1 1, so carry is generated, that this LED must get on. So carry equal to 1 and sum equal to 0. So this was the implementation of the first circuit. Now let us implement this second circuit. When in place of XOR gate, we have to just make this circuit. I will make another circuit in the other side of the breadboard. This connection will be as it is. This connection I will make in the another side of the breadboard. So let us do it. So now let us make this circuit for half adder. So first we need a 3 AND gates that we are going to get it from one IC. That is, the IC number is 7408, and we need a 2 NOT gates, that is from 7404, and we need a 1 OR gate, that is from 7432. So now let us connect according to this circuit. So connection can be made. So we need a totally 3 ICs. One is for NOT, one is for AND, one is for OR. So the IC numbers has been, you can see them on the ICs, that is 7404 is NOT, 7408 is AND, 7438 is OR. So these are the ICs I am going to do a connection. So as we connected in this, first we will connect a 14th pin has a VCC that I have connected, and 7th pin has a ground, and again here 7th pin is on a ground and 14th pin has a VCC, 7th pin on a ground, 14th pin has a VCC. Always the first connection is of 14th pin and 7th pin of every IC. So now let us connect according to this circuit. We are going to take a and B, two strands A and B, to the NOT gate first pins. First pin we will consider it as a. So second pin will get inverted, that is A bar, and third pin we will consider it as B, and fourth pin we will get it as a B bar. So we will connect it according to that. So first we will take a first pin as a and third pin has a B. So we will get an inverted output of A and B at the outputs of NOT gate. So you may be seeing a diagram of a NOT gate IC. According to that we will connect. So we want only 2 NOT gates. You can use any NOT gate from the IC. I am using the first and third pins NOT gate. So we will make A and B for the first and third pin. So let us connect it first. So I will take a blue wire as a and I will connect it at the first pin of the NOT gate. So I have connected a first pin at the NOT gate, and I will take a B. I will take a yellow wire as a B. So I will connect it at the third pin. This is first pin, second pin, third pin. So this is B. Now inverted outputs of A and B we are going to get it. For A it is A bar at second pin, and for B it is B bar at a fourth pin. So this is how we are going to give first input pins A and B. Now we will connect according to this. First AND gate, one input is from A and second input is from B bar. So first input is from A and second input is from B bar. So second input is from B bar. So let us connect according to that. Took first input from A and connected it to the first input of AND gate, and second input is B bar. So I have took it from the inverted output of the B. So I have connected it at the second pin. This was the connection for one AND gate. So these two inputs I have given. Now for the second AND gate, the first input is going to be A bar and the second input is going to be B. So let us connect according to that. So the next connection is going to be, so I have connected A to the first input and B bar to the second input. The next connection is going to be A bar to the first input and B for the second input of the second AND gate. We are going to use the another AND gate. So I am going to use the AND gate of 4th pin and 5th pin, and output is going to be at 6th pin. You can use any AND gate. So 4th pin. So this is 1, 2, 3, 4. So this is going to get it as a bar and this pin is going to get it as a B. So we will connect it from here. So A bar we are going to get it at this pin, that is second pin, is going to be connected at 4th pin, and we want a B. So B is at 3rd pin. So 3rd pin is going to be connected at a 5th pin. So this connection has to be made. I am going to connect them. So this whole AND gate connection I have done, first AND gate and second AND gate. Now both the AND gate output must be given the input as for a OR gate. So this is the last IC which is OR gate. I have to give outputs of first AND gate and second AND gate as the input to the OR gate. I am choosing a first OR gate. You can choose any OR gate. So let us connect it. So the first AND gate output is at 3rd pin. So taking the 3rd pin and giving the input at the as the input for a OR gate at the first pin. So one input I have given. So the second output is at 6th pin. So this is the 6th pin. So let us take the 6th pin and give a input as a second input. So I have connected a second input of the OR gate from the 6th pin to the second pin. So this is first pin, second pin, and third pin is output, that is sum. So I will take the sum. I am going to give sum by using an LED. So there is no need to be telling how to connect LED again. So the positive stand has to be connected at the output place and negative must be grounded as usual. So third pin is going to be the output for sum. So let us connect according to it. So I have connected a LED at the place of third pin. So this whole connection of the upper circuit I have done. Now the connection for the carry we have to do. The connection for the carry in this circuit and this circuit is same. So we are just going to take one A and B as input for AND and we will get a carry. So let us connect it. So A and B are at this place. This yellow wire is B and this. So for carry we have to connect this A and B. So let us take two other wires that I am going to use. So this is for one input of A and other input of B for the AND gate for the purpose of this carry. So these two inputs we have to give, and at the place of carry we are going to connect one LED. So we want a one more AND gate, that is third AND gate, from the same IC we are going to take which we have used for this connection. So we have used the two AND gates of this side. I am going to use one AND gate of this side. So I am going to use the pin number. So this pin number is 8, 9, 10, 11. At the upper side the AND gate is in this position. So input has to be given at the place of this pin number is 8, 9, 10. So this pin number is 10 and 11. 10 and 11 are going to be an input, and 9 is going to be a output. So we are going to connect the LED at this place. So let us give A and B at this place, and we are going to get it from the NOT gate. So this two A and B I am going to take it from these pins and I am going to give at this place and LED at this place. Let us connect it. So this is the how connection looks. So this is A and this is B. I have connected at the position of 10 and 9, and 8 is has a output. I have connected the LED. This is the positive strand I have connected at the output at the place of 8th pin, and this is the ground. I have took the ground connection from here. This is the ground pin, I guess. So this ground I have shorted from it here. So I got a ground. So now let us implement this truth table. So the output comes same for this both the circuit that we are checking. So we will put the one by one inputs and check for it. Now I have given a battery that this whole line is going to be positive and this side this whole line is going to be a ground. So now let us give the input. So the input pins are A, so this is B and this is A. Now let us check for the first input. First input is what? 0 0. For 0 0 it is going to be carry 0 and sum 0. So I will connect both the inputs for 0 0. So for both the 0 0, both the LEDs has been offed. So first input has been checked. For second input, A must be 0 and B must be 1. Let us do it. Just remove the B strand and put it to the 1. So LO1 is the B strand. So I have took B and I am going to put it at 1. So I have put it 1. So this LED is glowing. So it is for a sum LED and this is a carry LED. So we got it the sum as 1. So for second input, we have to exchange the strand. A is 1 and B is 0. So let us exchange the strand. So this is the B. I have took the B and I have made it as 1, and this I have took and I have made it as 0. So it is giving again 1, the same output. And for the last input, it is 1 1. It is giving carry as 1 and sum is 0. That we have made at this circuit. You can see both the A and B are 1 and we are getting carry as 1. So we will do the same thing in this. So we have to just take this wire, that is one input, and put it at a 1. So we got a carry. So carry is has 1 and this is 0. So both the circuits are working. Both are for 1 1. This circuit is at also 1 1 and this circuit is at also 1 1. So the same output. But the connection in this circuit is so complex, you can see by seeing the wires, and connection in this circuit is very less. You can say it is less complex. By using one OR gate, the circuit became less complex, and by not using one XOR gate, this became very complex. So here it is the use of XOR gate and it is not use of XOR gate. So when we use the XOR gate, the connection become little less complex, and if we do not use the XOR gate, the circuit become very complex. You can see the wires. This becomes the complex circuit from here to here, and meet in the next video. If you have any doubt, you can comment it down. Thank you.